Ever wondered why owls don't chew their food, but instead gulp down entire animals in one terrifying swallow? The secret lies in their incredible bone-eating superpower that revolutionized how predators hunt. Picture this. A great horned owl silently swoops down, snatches a mouse, and without hesitation swallows the entire creature whole, fur, bones, and all. Why would any creature choose to eat like this? It seems inefficient, messy, even dangerous. But here's the mind-blowing truth. Owls have perfected one of nature's most efficient digestive systems, turning what looks like a messy eating habit into an evolutionary masterpiece. The key to understanding this bizarre behavior starts with what happens after that big gulp. When an owl swallows prey whole, it's not just being lazy. It's following a brilliant biological strategy that's been millions of years in the making. Unlike mammals that chew their food to break it down, owls take a completely different approach. Their digestive systems are specifically designed to handle entire animals, bones included. The magic begins in their two-chambered stomach system. The first chamber, called the proventriculus, uses powerful acids and enzymes to start breaking down the soft tissues, the muscles, organs, and skin. But here's where it gets fascinating. The bones and fur that can't be digested get separated and moved to the second chamber, the gizzard. Now you might be thinking, but bones are hard, how do they handle them? This is where owls become true digestive wizards. Instead of trying to break down bones with acid, which would be incredibly energy-intensive, owls have developed a smarter system. The indigestible parts, bones, fur, feathers, and teeth, get compacted into a neat package called an owl pellet. About 6–10 hours after eating, the owl will regurgitate this pellet, effectively cleaning out its digestive system and making room for the next meal. But wait, there's more to this story than just efficient cleanup. The real genius lies in what happens to the bones before they get expelled. While the bones spend time in the owl's digestive system, something remarkable occurs. The owl actually extracts crucial nutrients from them. You see, bones aren't just hard calcium structures. They are living tissue filled with marrow, minerals, and proteins. The owl's digestive acids are strong enough to partially dissolve the bones, allowing the bird to absorb calcium, phosphorus, and other essential minerals that are vital for their own bone health and egg production. This bone-digesting ability gives owls a huge nutritional advantage over other predators. Think about it. Most animals that eat prey have to leave the bones behind, missing out on all those valuable nutrients. But owls get 100% nutritional value from their meals. It's like they're getting bonus nutrition that other predators simply waste. The evolutionary advantages don't stop there. Swallowing prey whole is also a safety strategy. When you're hunting at night and need to be silent to avoid detection, chewing creates noise that could alert other predators or scare away potential prey. By swallowing whole, owls maintain their stealth advantage. Plus, it's faster, they can consume their meal quickly and get back to hunting or protecting their territory. There's also the matter of energy efficiency. Chewing requires significant jaw muscles and energy expenditure. Owls have relatively weak jaw muscles compared to mammals because they don't need them for chewing. This evolutionary trade-off allows them to have lighter skulls and more efficient flight capabilities. Every gram counts when you're a flying predator. Now, let's talk about that incredible pellet system. The formation of owl pellets is a masterclass in biological engineering. As the digestible parts move through the system, the indigestible materials get wrapped in fur and feathers, forming a protective coating that prevents sharp bones from damaging the owl's throat on the way back up. The pellet itself becomes a time capsule of the owl's diet, which is why scientists love studying them to understand local ecosystems. The size and composition of pellets vary depending on the owl species and what they're eating. Larger owls like eagle owls can produce pellets containing bones from rabbits and other substantial prey, while smaller species might regurgitate pellets filled with insect exoskeletons or tiny rodent bones. Each pellet tells a story about the owl's hunting success and the availability of prey in their territory. But here's something even more astonishing. The pellet regurgitation process is controlled by the owl's nervous system. It's not an involuntary reflex like vomiting. It's a deliberate, timed process that the owl can control. They typically wait until the digestive process is complete and then find a safe, comfortable spot to expel the pellet. This level of control shows just how sophisticated this system really is. The evolutionary history behind this adaptation is equally fascinating. Owls have been around for about 60 million years, and their unique digestive system likely developed as a response to their nocturnal hunting lifestyle. Early owl ancestors probably started with more conventional eating habits. But as they specialized in nighttime hunting of small, quick-moving prey, the whole swallow method became increasingly advantageous. Over millennia, natural selection favored owls with more efficient digestive systems and better pellet formation abilities. Today, there are about 250 species of owls worldwide, and all of them share this remarkable digestive adaptation. From the tiny elf owl that weighs less than a golf ball to the massive Eurasian eagle owl with its 6-foot wingspan, they all practice this bone buffet approach to dining. It's a universal owl trait that demonstrates the power of evolutionary convergence. When different species independently develop similar solutions to the same environmental challenges, the nutritional benefits can't be overstated. By digesting bones, owls get a concentrated source of calcium that's essential for their own skeletal health and for producing strong eggshells. Female owls especially need this calcium boost during breeding season. The phosphorus from bones contributes to energy metabolism and cellular function. It's like nature's perfect supplement package, delivered in every meal. There's also an ecological aspect to consider. The pellets that owls regurgitate actually contribute to nutrient cycling in their ecosystems. As these pellets decompose, they release minerals back into the soil, benefiting plants and other organisms. It's a beautiful example of how predator-prey relationships create interconnected cycles within nature. Modern research continues to reveal new insights about owl digestion. Scientists using advanced imaging techniques can now observe the digestive process in real time, showing exactly how different prey items move through the system. Genetic analysis of pellet contents helps researchers track changes in prey populations and monitor ecosystem health. These studies confirm that the owl's digestive strategy is not just effective, it's brilliantly optimized for their specific ecological niche. So, the next time you see an owl depicted swallowing a mouse whole, remember that you're witnessing millions of years of evolutionary refinement in action. What looks like a simple, almost crude eating method is actually a sophisticated biological system that maximizes nutrition, maintains stealth, conserves energy, and even contributes to scientific research. The owl's bone buffet isn't just efficient, it's evolutionary genius at its finest.